Okay, today we're going to talk about absolute value equations. This is 1.4 in the Integrated Math 1 book. So as you can see these equations on the page here, every single one of them has an absolute value embedded in it. And today we're going to learn to solve those equations. But first we're going to go back and remember that the absolute value of a number is its distance from 0. For example, if you're looking at negative 5, the absolute value of negative 5 is 5 because it's 5 from 0. And the same with 5. Positive 5 is 5. The distance is 5 from 0. Okay, there we go. Okay, for any non-zero absolute value, there are exactly two numbers with that absolute value. For example, both 5 and negative 5 have an absolute value of 5. So both 3 and negative 3 have now absolute value of 3, and so forth. To write this statement using algebra, you would write absolute value of x equals 5. This equation asks what values of x have an absolute value of 5. The solutions are 5 and negative 5. Notice that the equation has two solutions. Okay, and this is an algebraic way of saying it. First we have with words, okay, then we have with numbers. When they replace the numbers with letters, that's algebraic, and then here's the graph. So if we were going to solve this equation, that's really easy, right? We know that two numbers have a distance of 12 from 0. So there they are, negative 12 and positive 12. Okay, so if we were going to write the equation as two cases, we would give the answers as this, or you could write that this is the old school way of writing the answer, or you could write x equals plus or minus 12. Now at this point, I'm going to tell you to watch out, because a lot of people see this and they get lazy and they think every single answer to an absolute value equation is plus or minus some number, and that is not true. So now we're going to go over the steps to solving absolute value equations. This table shows you the steps for solving absolute value equations. The first one you have to do before you can do anything else is get that absolute value alone. So for example, if I had the absolute value of x plus 2 multiplied by 3 plus 2, I have to get this all by itself. So I have to get everything away, I have to move this, and I have to move this before I can work on that. Then you have to rewrite it as two cases, and I'll explain that in a minute. We'll go over that. And then we have to solve the equation for each of the cases. So let's go back and talk about what that means. So first step, isolate the equation. So I'm going to get rid of the 3. Absolute value of x plus 7 equals 8. Now, before I go on, I want you guys to notice that I am never, ever going to touch what's inside the absolute value. It never changes. But the reason why we have two cases is because, remember when we had absolute value of x, there was the x equals, let's just put equals 3, equals positive 3, and x equals negative 3. So if you look at this case, I now have x plus 7 equals 8. I have to find out what makes this equal 8 and what makes this equal negative 8. But those are not your answers. So the first thing that I'm going to do is I'm going to split it. Okay, we're going to go back to solving. So now I'm going to have my two cases. X plus 7 equals 8. And x plus 7 equals negative 8. Oops, negative 8. Okay, so here's what you have to notice. This part is always the same as what's inside. Okay, always. The only thing you're changing in an equality is you have your positive and your negative outcome. And now I'm going to subtract 7 on both sides. I get x equals 1. Subtract 7 on both sides, x equals negative 15. Now that's a lot different than a plus or minus, so I'm going to go back and check. So I go 3 times 1 plus 7 equals 24. 3 times 8 equals 24. Then I'm going to go 3 times x, or not x, negative 15 plus 7 equals 24. I'm plugging it in for x. And then I'm going to go 3 times the absolute value of negative 8 equals 24. And the absolute value of negative 8 is 8. So again, those two answers work. Okay, for this one, all I have to do is get this over to this side. Absolute value of x equals 7. Then I just split it. X equals 7. X equals negative 7. And I'm done. Okay, this one. It's ready to split because the absolute value is by itself. Remember, this is a force field. Nothing can go inside. I can't distribute things in. I can't pull things out. So I'm ready to split. X minus 2.5 equals 8. X minus 2.5 equals negative 8. So I'm going to add 2.5 to 8. Remember, this part inside, always the same. So x equals 10.5. Add 2.5 to both sides. This is where you got to be careful. And x equals 5.5. So there's your two, negative 5.5. Be careful. So here's your two answers. Okay? Okay, so we want to talk about what each of these little symbols mean. These are from your book, and I want to go over them really quick. So, first of all, this is telling you absolute values are always positive. They always equal positive. But they can equal 0 too, or 0. Okay? So they're greater than or equal to 0. This one is telling you that if you have an absolute value with multiplication inside, you can split it. As soon as there's a plus or a minus in there, this rule does not apply. Same with dividing. You could divide and do absolute value of this over absolute value of this. Again, not subtraction or addition, just division. And this is just telling you that the absolute value of a number is the same as its negative absolute value, or the absolute value of the negative of it. Okay? All right. So, not all absolute value equations have two solutions. For example, if you have an absolute value equals 0, then there's only going to be one solution. So think about that. We can't split it into x equals plus 0 or minus 0. We just have solve for x equals 0, or whatever is inside the absolute value symbol. Okay, and I just discussed that. Okay, and if an absolute value equals a negative number, there are no solutions. This is not possible because of the definition of absolute value. It's the distance from 0, and distance is always positive. Okay? And I just told you. Okay, so in your journal you have this problem. So first thing you look at, is this absolute value simplified? Is it isolated? Yes. So I'm ready to split. But then I notice that it's equal to 0. So I'm just going to go 3x plus 12 equals 0. Subtract 12 from each side. 3x equals negative 12. And remember, when you split it, you take off the absolute value signs. So it's okay for x to be negative. It is not okay for the absolute value to be negative. So just keep that in mind. And we get x equals negative 4. So I can plug that back in there. 3 times negative 4 plus 12 equals 0. Negative 12 plus 12 equals 0. And the absolute value of 0 equals 0. So it works. Okay, so remember, it's okay for the value of the variable to be negative. It's not okay for the absolute value to be negative. Okay, for this one, I'm going to subtract 3 from both sides, and I get the absolute value of x plus 4 equals negative 3. As soon as I see that, signs should blare in my head. Stop! That is not possible. The answer is the null set. An absolute value can never equal a negative number. Okay, for this one, I am going to subtract 2 from both sides. This is where you've got to be careful. I get negative absolute value of 2x minus 5 equals 5. But I still have this, which is connected. Think of it like a negative 1. So I'm going to divide by negative 1. I get the absolute value of 2x minus 5 equals negative 5. There goes that stop sign again. Cannot have it equal to a negative, so it is the null set. But you want to be careful in cases like this. What if the problem had been 2 minus absolute value of 2x minus 5 equals negative 7? Okay, then I'd subtract 2, and I'd get negative absolute value of 2x minus 5 equals negative 9. And then when I divide it by 9, or negative 1, it would be a positive number, and so I could still solve it. So always take the time to calculate it until it's isolated. Don't make decisions about it back here. Isolate it to see if it's going to work. Okay? I'm talking about this one. Okay, so now when you're ready to, you're going to do these problems in your journal, and you're going to pause the video, then I'll give you the answers, and then we'll go over them later if you need me to. There's the answers. And now we're done with our video. So we'll go over, now we're going to do how to create an absolute value equation. So inline skates typically have a wheel with a diameter of 7.4. The wheels are manufactured so that the diameters vary from this amount by at most 1 millimeter. That's a really tiny amount. So they want you to write an absolute value equation. So here it is, but I'm going to explain it. So the ideal diameter is 7.4. But if they have one that's plus 0.1, that's still going to be okay. And if they had one that is minus 0.1, that would be okay. So we could go ahead and just do that and get 74. So it's 74.1 or 73.9. So that would be the range that's allowed. But when they want you to write an absolute value equation, what you need to remember is that you put your ideal measurement, the one you're shooting for in manufacturing or whatever, or if you're talking just about numbers, you put the midpoint here with a minus sign. And then the amount that you're allowed to vary by is the equal. And sometimes students will get those mixed up and they'll put the big number over here, but as soon as you try to solve it, you'll figure out why it's wrong. So be careful. Okay, so in your book, they had this problem, and it said the shoulder heights of the shortest and tallest miniature poodles are shown. So represent these two heights on the number line. So there they are, 10 inches and 15 inches. Okay. Write an absolute value equation that represents those heights. So when you have two numbers and you want to come up with an absolute value equation, we're going to put the midpoint here. Okay. And then the variance goes here. So first thing I have to do is find the midpoint. So I go 10 plus 15 divided by 2 is 25, divided by 2 is 12.5. So that's the number that goes there. That's my midpoint right there. Okay, because now the distance is going to be the same. So the next thing you have to find out is, what is this distance? And it should be the same. So 15 minus 12.5 equals 2.5, and 12.5 minus 10 is 2.5. So that is our allowable variance. Obviously with dogs, it's not going to be exact. It's not like manufacturing that has to be exact. You might get a big teacup poodle and you might get a small, miniature poodle. So I know they all have fancy names. So that's how you create the equation with numbers. Okay, so now I'm going to go over the worked out problems if you need them. Okay, so the first problem that we have is all ready for us to go. The absolute value is isolated, so we're going to go ahead and split it. Y plus 2 equals 8, and y plus 2 equals negative 8. So subtract 2 from both sides, and we get y equals 6. Subtract 2 from both sides, y equals negative 10. So if I'm going to graph it, I have 1 there and 1 there. Now, remember what I said about x minus the midpoint equals the variance? So I want you to think about that really quick. And since this one is plus 2, then it must be minus negative 2, which would make it plus. Zip zap would plus it. So negative 2 is my variance. The distance here is 8. The distance here is 8. So I just wanted to show you that in terms of that problem. Okay, for number 3, we're going to divide both sides by negative 4. We get the absolute value of 7 minus 6k equals negative 7 over 2. Stop sign in our brain, because that is not possible, cannot equal a negative number. So that is the null set. Okay, this one, absolute value of d over 3 equals 3. It's ready to split. So I'm going to do it over here. D over 3 equals 3, and d over 3 equals negative 3. So I'm going to multiply both sides by 3 to get rid of that denominator. D equals 9. And multiply both sides by that 3 to get rid of the denominator. D equals negative 9. So we have 9 and we have negative 9. And if you look at that, there is no number here, so the midpoint is 0. Okay, for this one, first thing I'm going to do is subtract 10. I usually do opposite of PEMDAS, so you start with the addition and subtraction. Believe me, you want to do that because then it usually will divide out correctly for you. So just trust me on that one. 3 absolute 2x plus 5 equals 27. Divide both sides by 3. I get the absolute value of 2x plus 5 equals 9. I'm ready to split. 2x plus 5 equals 9. Again, the middle part's always the same. And that equals negative 9. So we have the positive answer and the negative answer. Now we're going to solve. 2x equals 4, x equals 2. So there is one answer. And we subtract 5. 2x equals negative 14. X divided by 2. X equals negative 7. So negative 7 is right there. So now you can see that those are the two answers for that problem.